In what topic of physics? Where was the first time that I talked here so far? Energy. So, from here, energy. And what type of energy conservation? Theorem 1, 2, or 3? The third, which was EI is equally final. You remember that?
Yes.
So, combining these two topics, momentum with collision and energy swinging, we can't solve the problem. So, how can we solve the problem? Let's start. You start from what we are looking for. In physics, you start solving the problem from what we are looking for. And if we need an extra information, we will go and find it. So, here you told me that this up to here is collision. In that part, we will use the law of conservation of linear momentum. And in this part, we will use what conservation law? In this part, EI is equally final. That's it. So, since we are looking for U, from which topic we start? We are looking for U initial. We start with linear momentum conservation or with energy conservation? We are looking for U. Where is U? At the beginning or at the end? At the beginning. So with what topic we will start? Linear momentum. So we will say Pi is equal to final because we want to find U. And now we go by inspection. Which of the two objects has momentum at the beginning? The bullet is moving, the block is stationary. The bullet. So we say the momentum of the bullet is letter M times U. There is no momentum on the block. Equal. Then the two objects get embedded. I mean, the two objects get together as an assembly. What will be the total linear momentum of the assembly? M plus the total M, which is M1 plus M2, time what? Time what? Time V after the collision. And we check what we have and what we don't have. Do you have M? Do you have these two M? So let's say that I give the mass. What are the? I gave the mass 0.050 kilogram. Let's say 50 grams. And the mass is 3 kilograms. Besides that, I give L 1.5 meter, the angle 20 degrees. Find U. How can we find U? From here, U will be M plus M over M times V. But we don't have V. What can we do in order to find V? So as you can see, V is in the transition point between the collision, between the topics, collision and energy. How can we find now V? What we use? These are we already used. Now, in the second part, when it's swinging the pendulum, what theory I said that we will use?
The third law.
EI is equally final. The third law, conservation law in energy. So we can use EI is equally final. And now we go by inspection. Because we want to find the speed after the collision, which is this. So, imagine that this is the case. This is the pendulum, right? And this is the projectile. Imagine that these stick together. So it will go like this, and this will move a little bit, but they will stick together. So at the beginning, what type of energy has the combination. These stick together. At the beginning, what type of energy will have? Kinetic. And what will be the formula for that kinetic energy? What mass? Both together. Times v squared equal. At the end, when this swing to the maximum height, what type of energy? And what is the potential energy in the pendulum if you have the angle and the length? Oh, by the way, both masses. Both masses. So both masses cancels out, and we get that V is the square root of 2GL1 minus cosine theta. And that's it. We found V. Once we found V, we come here, we plug it in. Again, it's the use of momentum for the collision. And any other topic, you have to remember the previous topics that we learned in physics. Energy can solve the problem. Example. Look at the study guide. And I give examples on the study guide. So similar, problem related to this, to the ballistic pendulum, will be problem number 4. They can state differently, not necessarily. This is the general theory. Problem number 4. Problem number 6. Problem number 9. Problem number 10.